This method of factoring that we're going to do today is called grouping. We use grouping when we have more than 3 terms. In this case, we have 1, 2, 3, 4, 5, 6 terms. What we want to try to do is group things together that have the same letter. Because none of them have the same letter, we can't take the greatest common factor out, but we will do that once we group it. So if you look at this term, and this term, and then you look at this term, and this term, we have the same letter in those 3 in red and those 3 in blue. So the ones in red I'm going to group. So 8x plus 4bx plus 4cx. I'm grouping together. And then I'm going to group the 6ay plus 3by plus 3cy. Okay, by doing this, I can now find the greatest common factor for just this grouping. So in this grouping, I have a 4 and an x that's in common in every one of these. So if I take a 4 and an x out of each of these terms, I get a 2a, I get a b, and I get a c. So this is using the greatest common factor method for just this part. Now I'm going to go over here and do the same thing. The blue, what's common between these 3 terms, and it happens to be a 3a. So it's a positive 3y, I mean. So now we're going to pull the 3y out. We get 2a plus b plus c. So by pulling out the greatest common factor, we're left with something in the parentheses. Now if you look at these two, what's in parentheses, if they're identical or can be manipulated to become the same, you have your first factor, 2a plus b plus c. Our other factor will be what's left over, which is the 2 greatest common factors put together. And so our answer here is in black is that. So once again, we have more than 3 terms, so we're going to group. So in red, I'm going to find all the ones with the same letter. In this case, I'm going to find the ones with the y, and they're not written next to each other. So I'm going to rewrite it, the ones with the y, in red. And then in blue, I have the ones with the z. So I have a negative 16fz, a plus 8hz, and a minus 12gz. Now I picked y and z, but you could have picked, obviously, if you look at this, g and h. I just picked y and z. So now that I have my y, what's common between all the y values? There's a y, and there's also a 5. So if I divide the 5y out, I get 4f plus 3g plus and minus 2h. And now in the blue, I look at what's common, and I have the z, because I already determined the z's in every one of them, but I also have a, looks like it's a 4, 4z. So I'm going to divide, and actually it's a negative 4. So when I divide a negative 4 into 16fz, I get a positive 4f, and negative 4 into 8h is a minus 2h, and negative 4 into negative 12 is a positive 3y. And the reason why I picked the negatives is because I'm trying to make this look like this. And since I needed to have a positive, I divided a negative by a negative. And now I have in black here, what's in the parentheses is exactly the same. And I'm just going to write it like this. And then what's left over is a 5y and a negative 4z. So what's out here on the outside, the greatest common factors, becomes our other factor. So what's in black is our factoring problem.